Say we are testing this null hypothesis where the population mean is, according to null hypothesis, 80 units, and the alternative is that it's greater than 80, and we are going to base our test on simple random sample of size 40, and the level of significance is 0.01. And we are given that the population standard deviation sigma equals 15. So how do we make a decision here? We make a decision that if we get a p-value, that if we get a sample mean whose p-value is, or the p-value of the test is less than 0.01, then we shall reject the null. Okay, so which means that here are our null and alternative again, and this is our decision rule. Now, this is a graph of the distribution of sample means, which we denote by x bar in this, in our calculations. So the distribution of sample means is given by this normal curve if we have sample of size 40 and the standard deviation of the population is 15. So what we would do is that, say this right tail in the area is 0.01. So if our sample mean comes out to be a value to the right of this point, then what would happen? The p-value, that is the right tail, will be less than 0.01, and we shall reject the null. So what we have here is this, that if say our sample mean comes out to be, just a second, comes out to be greater than this x bar value here, okay, then we shall reject the null. So let's see what this value is. Now you see the right tail, or the area to the right of this value, sorry for making it too bold, but anyway, the area to the right of this value is 0.01. So what will be the area to the left of this value? 0.99. That is, we are going to look for the 99th percentile of this distribution, whose mean is 80, and the standard deviation is how much? Remember this, that you had let me get that back for you, that you had a standard deviation, population standard deviation as 15, and the sample size is 40. So the distribution of sample means is how much? 15 over square root of 40, right? Okay, so let's take this value there, and just to keep in mind, okay, so here we have this, so we are going to look at the 99th percentile. That's what this value will be. So let's look at the 99th percentile of the normal distribution, okay, with mean of how much? With mean of 80 units, right? And a standard deviation of how many? Right here, 15 over square root of 40 units, right? Okay, so let's go get our calculator up here, and then we go to second vars in order to get to the distribution. Then we are going to compute the percentiles. So inverse norm is the method to do that, and then the mean is how much? 80, and the standard deviation is 15 over square root of 40, right? And there you go. So it comes out to be about how much? 85.52, right? Okay, so this value is right here. The value there would be, let me write it for you, 85.52, right? Okay, so what our strategy is going to be now, we shall reject the null, right? Excuse me, shall reject the null if what happens, our sample mean x bar, okay, is what? Is greater than how much? 85.52 units, right? Otherwise we will do what? Otherwise we will not reject it. Okay, so again, we shall reject the null if the sample mean x bar is greater than this value, and not reject it if it's less than this value, right? Okay, so now our objective for this session is to compute the probability of a type 2 error. So let's first recall what a type 2 error is. So remember, a type 2 error takes place is the acceptance or non-rejection, okay, of a false null hypothesis. Okay, so now what we want to do is, the way we are going to conduct our test, we are going to reject the null if x bar is greater than 85.52. so we shall have what? We shall actually not reject the null. Okay, so let's just insert it here. So we shall not reject the null. Excuse me for a second to fix this line here. One moment. So we shall not reject the null if x bar is, well, let's just keep these nots here. Okay, if x bar is not greater than how much? 85.52, right? Okay, good. So if we look at it, so what we are going to see here, let's say actually or in fact, so if in fact or actually this is the case and we are not rejecting the null hypothesis, if this happens, then we are committing a type 2 error. Okay, so once again, if actually the population mean is more than 80 and we did not reject the null, then we committed a type 2 error, right? So now this could be wrong in many ways. That is, mu could be, say, 81, could be 81.3, could be 84, 80. There are many values. Like any value greater than 80 makes a case against the null. All right. So our probability of type 2 committing a type 2 error will depend on what the actual value of mu is. So let's go towards that calculation. Okay, so let's just, for example, compute the probability of a type 2 error when in fact we have this, that the mu is actually how much? 81. So that means what? We are going to compute the probability that we shall get a sample mean of less than 85.52, assuming that the less than 85.52, when actually mu is how much? 81. So how do we do that? We shall take the calculator. Let's go ahead and compute the normal CDF. Now we're going to compute the probability for less than 85.52. In this case, for all practical purposes, we can enter 0 for the lower bound. Okay, and for the upper bound we have 85.52, and then the mean actually is how much? 81, right? And the standard deviation is, we can keep the same standard deviation here. Okay, so we have, so what's the probability of type 2 error in this case? Is pretty big. But notice this, that of course it will depend on the context, that the null is not really that badly wrong. All right. Okay. So anyways, in this case, what happens? The probability of a type 2 error comes out to be how much? 0.972 approximately. Okay. So what we did was that we computed for this situation that null is 80 and the alternative is mu is greater than 80. And so when actually the population mean is 81, which favors the alternative, then we have a probability of committing a type 2 error. How much? Is quite big, 0.972. So let's see what happens when we go more and more towards null being wrong. I mean, I'm just trying to put it in as informal language as I can. So say mu is 82. So what do? We can just recall this thing, and all I have to do is what? Just change this population mean in here to 82, and you can see that it starts to decline now, right? Okay, so let's just put this value up here. Okay, so, and again, I mean, this is the way that you decide how big a sample size you want, if you want your test to have enough power. Okay, so now let's look at this scenario when this is 83. Okay, so there we go. And yeah, what I would do, I'll just change it to 3 and see how it changes. Well, it has declined. So, and we will proceed like this in here. That is, okay. All right, for 84, we will just do this, change this to what? 4, and there we are. Well, it has declined further, and so say we have, so you can see it goes on declining as we go to the right. So let's look at a scenario, say, where mu in fact is, say, 90 units. Okay, sorry about that. All right, so what do you see if it goes as far as that? Let me get the calculator back up. Then, oh, sorry. Okay, so here we have this, and now we will change this 84 to how much? Say 90. All right, and here you can see when it's that bad, then our probability of committing a type 2 error declines. All right, so I'm going to go further into that, but let me do this here. Let me quickly abbreviate the whole procedure for you by using a different examples of same kind, just a different example, so that you can see that how you can quickly compute the answer of this type of a problem is if it shows up on your exam. So let us consider this scenario that we are testing this null hypothesis that population mean is 150 and the alternative is that it's greater than 150, and we're going to take simple random sample of size 45 and use a level of significance of 0.05, and we are given that the population standard deviation is how much? 29 units. So now if this is the case, then we have the standard deviation of sample means, which are denoted by x bar, how much? 29 divided by the square root of 45, the sample size. So what do we do here? That we shall not reject the null, okay, the null if the sample mean of the sample that we are going to take, okay, is less than the 95th percentile, because our right tail has to be what? 0.05 in the area, that is 5% of the area is in the right tail. So 95% of the area is in the left, on the left side. So of the normal distribution with what? Mean as how many? 150 units and standard deviation of, as we just saw by central limit theorem, we know that that has to be how much? 29 over the square root of 45, right? Okay, so that's what our rule will be. Now let's say that in this question we have to do this, that to find the probability of a type 2 error if in fact the null is wrong, and it is wrong to the extent, I'm saying that in formal language, so in fact the population mean is how many? 200 units. So that's what we have to work on. So now after having gone through all that, we can do it in a much quicker fashion. That is, first we compute the percentile, right? They're taking the inverse norm or using the inverse norm for 95th percentile of a normal distribution with the mean as how many? 29 units and standard deviation of how much? 29 over square root of 45. So how much is that? It's about 157.11. So we are not going to reject the null if the sample mean comes out to be less than that. So now let's see what the probability is that the sample mean will be less than that if population mean in fact is how many? 200 units. So what we would do is, now this time we are going to go to normal CDF, because we know that we are looking at the area below. Now here we could enter 0, but let's just be like, just apply the way we have been going. That is, we take the lowest possible number because we don't know the context here, so that will be safe to do. And just a second, this is wrong. Who is our upper limit here? Upper limit is this value 157.11, which you can enter by putting second answer, right? And now our mean is how much? 200, and a standard deviation, of course, remains the same. So you have what you got. You got this, and you can see in this case it's approximately how much? 0. Okay, just because that's, and it all depends on your level of significance, the sample size, and of course the spread of the population. Okay, let's just for sake of practice, let's just do one more. That say it was 170 instead of 200. Okay, all right, then let's see how well it will work. So we will do this, we will go second enter, right? And now we just have to change, just a moment, and now I think if I put second answer, that will not work. Okay, I'm sorry about that. Let's just do this, and here we go. We have this 150, and then 29 over square root of what? 45. Okay, and then we will take normal CDF, and I'm just going really just by the books here, and I could have put second answer again, but I didn't, so let's not worry about it. Here if we put 170 and then again 29 divided by square root of how much? 45. So this time it's like 0.001. So this will still work, like pretty powerfully. Okay, so and depends on what you really want to do. We just saw how do we do the calculations. Okay, and we'll do one more example and then move on. Just a moment, I didn't copy it very well, so one sec again. Here we are. I'll just put the whole thing together. Okay, so we have this here. Okay, so let's do just one more example, and then I'll just take your questions if you didn't understand it. So this time we are going to look at a left-tailed test. That is, here say we have the null as mu equals 25, and the alternative is it's less than 25, and our scheme is that we have level of significance 0.01, sample size of 35, and the population standard deviation is given to be 7. And so the standard deviation of the sample means, again I just didn't pay attention to that earlier mistake of mine. So sample mean x bars, they have a standard deviation of how much? 7 over square root of 35. Now in this case our decision rule is going to be different. So now in this case we shall reject the null if the sample mean comes out to be where? See, falls on the left of this value, where what we have, where this tail area is how much? 0.01. So that means that we are along the earlier lines, that we are not going to, so shall not reject the null if the sample mean is greater than the, well, in this case, what? The first percentile, right? Okay. So now, say our task this time is to obtain or to compute the, okay, so to compute the probability of type 2 error if in fact, say, the population mean is, say, 20 units. All right. Okay, if it's 19, it will be different, 17 will be different. So let's see what it comes out to be. So we'll get the calculator, right? And so here we go. So we go to inverse norm, right? 0.01. Then we have 25 for the mean. Okay. And then we got 7 divided by square root of what? 35 for the standard deviation. So if it's less than, if it is greater than 22.25, then we are not going to reject the null hypothesis. So this time we are going to go to the right, all right, for the non-rejection region. So what do we do? I think the easiest way to do would be just put second answer. We are going to the right, and well, it can go as far as the calculator can handle. And then we have what? Actually, the sample mean is how much? Sorry, the population mean is how much? 20. All right. And the standard deviation will still be taken as the same, what we got here, 35. Okay. So what is the probability of your type 2 error in this case? It's approximately 0.0288, we can say. Okay. So just do your calculations and let me know if you have any questions, and I shall elaborate it more. All right. Okay then. So we are done with this here. Let me just put this in here, and I shall post this script on our web page.